We already seen how to find the derivative of a sum, difference and product. In this video, we're going to learn about how to find the derivative of a quotient. A question would be find the derivative of the function 4x plus 3 on x. 4x plus 3 on x. Okay, so something of y equals 4x plus 3 on x. So this is of the form u on v, y equals u on v. With the way in this particular question, u is 4x plus 3, v is x. Oh, both these functions, u and v, you can find the derivatives. So if the function is of this form, we can find the derivative of the function y dash equals denominator times the derivative of the numerator minus u, the numerator, times the denominator's derivative divided by the derivative, the denominator square. Alternatively, you can express this in Leibniz notation by replacing y dash with dy on dx. It's the same thing, but different way of writing it. And u dash is du on dx and v dash on as dv on dx. It's the same expression. You can use whichever is more comfortable to you. Okay. So coming to this question, to find the derivative of y equals 4x plus 3, the first thing I'm going to do is finding the derivative of u dash and v, finding the derivative of u and v, and then substituting back into this equation. Let's do that here. Let's do that now. U equals numerator, which is 4x plus 3 in here. And you need to find u dash, and v equals x, and you need to find the derivative of v as well. Okay. First, let's find the derivative of u. Derivative of u is derivative of 4x plus the derivative of 3. For finding the derivative of 4x, we have to use the power rule. There's a constant 4. Just write it as such. That's always we do with the constants. And then the power rule is the derivative is n x to the power n minus 1, where n in this case is the power of x, which is 1. So it's a 1 x to the power 1 minus 1. 1 minus 1 is 0. So x to the power 0, any variable to the power 0 is 1. So it's simply 1. So the derivative of x is 1. Okay, so it's a 4 times 1, which is 4, and the derivative of 3 is 0. Constant term, derivative is 0. And taking the derivative of x, we already have done that for this question. So it's 1. Okay, let's now substitute that into here. V is x times u dash 4 minus u, it's a 4x plus 3 times v dash, which is 1, divided by v square, which is x square. So let's simplify that a little bit. So this one now becomes a 4x. You need to multiply this minus 1 with all the terms inside the bracket. So you're expanding the bracket. So it's a minus 4x minus 3 divided by x square. 4x and minus 4x cancels out, and then leaving minus 3 in the numerator, minus 3 on x square. So that's the answer for the derivative of y. Okay, so it's a simple process, isn't it? And let's now do another question. This time a little bit more complex one. Y equals e to the power x divided by e to the power 3x plus 3. Okay. Same process as before. We have to find the derivative of numerator. So the numerator is u, which is e to the power x, and v is the denominator, which is e to the power 3x plus 3. So you need to find the derivative of each of these. You need to get u dash, v dash, substitute back into there. Okay. So u dash, finding the derivative of u, e to the power x, is very simple. If you know the derivative of the exponential function, the derivative of the exponential function is the function itself. This is particularly simple because so it's x with coefficient 1. And this is very simple for this particular one because the coefficient of x is 1. And so the derivative is e to the power x. Okay, now let's find the derivative of v. So the derivative of v is derivative of first term plus the derivative of the second term. So it's a d on dx of e to the power 3x plus the derivative of 3, which is 0 because it's a constant. Okay, so that's basically the derivative of e to the power 3x. So if I'm taking, so we need to find the derivative of e to the power 3x. It's not as simple as this one because the coefficient of x is 3. We need to apply the chain rule. So the chain rule is dy on dx equals dy on du times du on dx. So this yu, all these things we use in multiple contexts, so don't get mixed up. So in this particular case, y is 3x. If it's too much confusing to you, you can change the variable from u to w, for example. It doesn't matter. Okay, so that can be done because it's all variables, so you can choose whatever you like to avoid any confusion if you have. And anyway, this w or u, whatever you chose, is actually the inside function. So what I meant by that is you're going to take exponential of 3x. So 3x is the inside function. So you're going to make that substitution, u or w, because I changed that to w, is 3x. And then you're finding the derivative of this function. So this function then becomes e to the power w. And you're finding the derivative of this function with respect to w. And that's now is something like you're finding the derivative of e to the power x with respect to x. You're taking the derivative of w with respect to w. So that's simply e to the power w. And then you need to find dw on dx, which is the derivative of this function. So derivative of 3x with respect to x, which is 3. So we can substitute that in here, so that then becomes dy on dx equals dy on dw, which is e to the power w. So don't take this w as such into this final expression, because w is something you introduced and you can't have that in the final expression. So w is 3x, so I'll make that substitution back. E to the power 3x times dw on dx is 3. So it's basically this dy on dx, or v dash in here, is 3 e to the power 3x. So it's basically we have to do a little bit of extra work to find the v dash. Okay, so now we have u dash, v dash. It's all about substituting all these things into this equation. Let's do that. So y dash equals v, which is e to the power 3x plus 3, times u dash, which is e to the power x, minus u e to the power x times v dash 3 e to the power 3x divided by v square, which is e to the power 3x plus 3 the whole square. Okay, let's do a little bit of tidying up in the numerator. So the first thing we want to do is eliminate the brackets. So we need to do e to the power x times e to the power 3x first. If you remember the index rule, a to the power m times a to the power n equals a to the power m plus n. And using that one, this is nothing but e to the power x plus 3x. You are just adding up the powers together. So it's e to the power 4x. Okay, so let's make that substitution. Okay, so that's then becomes e to the power, so you multiply this with this one, so that becomes e to the power 4x plus 3 times e to the power x, multiplying this together, minus 3 e to the power x times e to the power 3x as the same in here, e to the power 4x using the index rule, and divided by e to the power 3x plus 3 the whole square. So we can make more simplification in here, because this and this can be these two terms can be clubbed together, because they both have the same e to the power 4x. It's a 1 minus 3 is the subtraction of the coefficient, which is minus 2 e to the power 4x, and 3 e to the power x, the middle term, divided by e to the power 3x plus 3 the whole square. Okay, so that's the final answer. Okay, so this is not simple as the first one, because we needed to use a chain rule, some index laws, etc. But this is often the case. In one single question, you may encounter with quotient rule, product rule, chain rule, power rules, etc. So the only thing you can do is master all these laws and techniques and Be confident with any question.